realize you guys, it's going to look weird because I'm looking at my other screen. So I promise I'm looking at you and not like looking off into the distance. But I just have the dual screen set up for the presentation. Hello, welcome to sustAInable, which is ACM AI and ACM Impact's event talking about how artificial intelligence and specifically machine learning can be used to tackle climate change related issues. My name is Jason. I'm an AI officer and I'm also on the Impact team. And co-hosting with me today, I have Ava and Aman who can introduce themselves. Ava, would you like to say something?
Yeah, my name's Ava. I'm a first year EE major and I'm also an ACM AI officer.
Hey, my name is Aman. I'm also an ACM AI officer and I attend ACM Impact meetings from time to time. So let's get started. The schedule for today is we're going to have an introduction to climate change and all the problems plaguing our Earth today. And then we're going to have a quick introduction to machine learning, what machine learning is about. And then we're going to go over some tools that you could possibly use later during the discussion section. So these are like some machine learning, some wide machine learning topics that you could apply when you're coming up with solutions. And then the fourth part is like the main part, which is like the forum section when you'll be splitting up into breakout rooms based on topics, based on different topics. And then you can discuss with other people and come up with your own solutions to climate problems. I'll pass it off to Ava to discuss climate change.
Okay, so we're going to be giving a little bit of an overview about climate change, just to make sure everyone's familiar with the things that we're trying to target. So climate change is a problem that has been around, obviously, for a very long time, but greenhouse gas emissions have risen sharply since the 1950s, which is why we're focusing on it so much, in this century as things are starting to get worse. If you look at this next graph, you can see the carbon dioxide concentration in the air like skyrocketing in the 1950s. And right now we're at a very critical point where we have to make some changes to our daily lives and changes to our policies in order to delay some very lethal impacts to our Earth and our environment. So as for some international climate agreements, we've tried times and times before to make some international climate agreements to be able to regulate countries and their use of greenhouse and like their exertion of greenhouse gas emissions into the air. But we see that recently, with like, for example, the Paris Agreement, we're aiming to keep the warming below 2 degrees Celsius from forever ago, pretty much. So obviously we know that the Earth is warming and the Paris Agreement wants to make sure that that warming stays below 2 degrees Celsius. And so in the next slide, we'll see that our current policies kind of lead us toward 2.8 to 3.2 degrees Celsius increase in temperature. And so there are some really big impacts to even like a 2 to 4 degrees Celsius increase in temperature. Even though it doesn't seem like that much, it actually is a lot. So if the world temperature rises by 2 degrees, all the mountain glaciers and rivers will start to disappear, which means that our sea levels will rise will rise a lot, and mountainous regions will see even more landslides because the water that is kind of keeping those mountains together will begin to melt. If we get to 4 degrees Celsius increase, we're pretty much just going to see the hottest temperatures we've ever seen, and there are going to be many places on Earth that are just completely inhabitable by humans. And so it's really important that we stop this from happening. So just to look at a little bit more about the impacts of this crisis, the first impact that we see are heat waves and increasingly frequent fires. Obviously in California, we've seen a lot of heat waves and fires in the past summers, and these are extremely dangerous for people. They are displacing people's homes, they're killing our wildlife. It's extremely important that we care about our environment as it is changing the way that we live fundamentally. We are seeing next is also water scarcity and droughts. We see, in countries like Africa, there are droughts, but also in like our own home in Los Angeles, we're in a drought. In California, we're in a drought. And also we see in countries like India, the droughts there are causing farmers to pretty much lose their jobs and go jobless. So it's extremely important. Again, the environment is extremely important for people's livelihoods and for people's jobs and for people's happiness. And so there are some other effects as well, such as crop failures, rising coastlines. So in that picture below, you see the red area is like if all of Greenland's glaciers were to melt, then the sea level would rise and all of that red area would pretty much be underwater. And there's a lot of people that live there. So what's going to happen to all the people that live there? What's going to happen to all the houses and infrastructure there? They're going to be destroyed. So it's important that we stop that from happening. Pollution-related deaths, shrinking marine life populations, and also there will be a lot of climate refugees, which are pretty much people who are displaced by climate issues and have to be forced to go somewhere else. But you know, issues with refugees can be extremely difficult as sometimes there's nowhere for them to go or no one will accept them. And so there is a solution, and there could be a solution to this, and that is artificial intelligence. So according to the Capgemini Research Institute modeling, AI will likely reduce GHG emissions by 16% by 2030. So that's extremely important, and that's why we're looking at artificial intelligence for a possible solution to climate change today. And then next, I will pass it on to Jason to talk about machine learning fundamentally and how it works.
Yeah, thank you, Ava. So next we're going to talk about machine learning at a rather high level, but we hope that this will give you a good insight into what artificial intelligence really means and what it's capable of, and we'll also talk about where the field is going. So to talk about machine learning is a subset of artificial intelligence, and there's really 4 schools of thought on AI, so I want to give an overview of what these 4 schools of thought are before talking specifically about machine learning and how it fits into this bigger picture. And there's 2 axes that you can think of when it comes to acting versus thinking and human versus rational. So one very old school of thought is the Turing Test, also called the imitation game, and that asks, can machines act like humans? Another school of thought asks if machines can solve problems the same way humans do. Can they model human cognitive behaviors and problem-solving abilities and address issues the same way that we do? And then there's a rational agents approach, which looks at if machines can maximize the expected value of given performance metrics based on what they currently know. And then there's a laws of thought approach, which is asking if machines can solve problems described with logical notation. And while all 4 schools of thought about AI are interesting, what we're really concerned with today is the standard model, which is that AI is the study of intelligent rational agents. And more specifically, we're looking at machine learning, which falls within the rational agent approach. And machine learning is a subset of AI that provides computers with the ability to learn without being explicitly programmed. And I find that there is a really helpful diagram that we at ACM AI have been using a lot in our slides to explain the difference between machine learning and AI. And it's that you can think of machine learning as a bubble contained within the larger field of artificial intelligence. So AI might encapsulate things like if-else statements, decision trees, data mining, whereas machine learning might cover methods like supervised learning, unsupervised learning, reinforcement learning. And these are just a few examples. But the idea here is that everything that is covered by machine learning is AI, and not everything that's AI is within machine learning. And I'm going to pass it off to Aman to talk about some specific tools that I mentioned here and how we can use these for addressing climate issues.
Okay, thank you so much, Jason, for that insightful introduction to machine learning. I'm going to talk about some machine learning tools that you could use when you're coming up with solutions to climate problems. The first tool I'm going to talk about is computer vision. So computer vision is a branch of machine learning where you feed a computer with quote unquote visual information such as images and videos, and the computer learns to recognize different objects and different patterns within that image. I said quote unquote visual information because the computer actually gets in information in terms of like pixel values and stuff. So an example of an application of computer vision, for example, is this image right here. Basically, if you can train a computer to take in an image of a road and identify different objects such as people, traffic lights, cars, trucks, and a possible application for such a model that takes in a picture of a road and detects these objects is autonomous vehicles, for example. So the advantage with computer vision is that you can train computers to detect pretty much any kind of pattern or object in an image that you want. So that can be a very powerful tool to have in your back pocket. The next tool this is not really a tool, but it's a concept that a lot of machine learning algorithms try to achieve, and that is classification. That's one of the goals that machine learning algorithms try to attain. And so basically, you can train a computer to take in an input such as an image. For example, there's a cat image here, and you can train the computer to sort that image into predetermined classes. For example, this model here, it takes in an image of an animal, and then it sorts it into, and it decides whether it should put it into a class of pandas, dogs, or cats. Next up is clustering. And clustering is looking at the data that we have at our hands and letting an algorithm categorize it into different groups or clusters. For example, let's say you have an online store, such as Amazon, that sells pretty much everything. You can train a computer to look at your sales data, and then you can train it to identify different clusters in your data based on people's shopping habits. For example, the blue cluster here could represent a group of people that have pets. So you could recommend pet food and pet toys to them. Another cluster could be the green cluster, and that could represent college students to whom you would want to recommend stuff like new laptops, headphones, or stationery to. And then the final black group could be something like gamers who are like interested in video games or gaming headphones, etc. So clustering is a tool that helps you break down the demographic of your study into smaller groups, and so that you can treat each group differently based on their habits or their needs. Something that could be confusing here is what's the difference between classification and clustering. In classification, you have some predetermined classes. For example, we had pandas, cats, and dogs, and you classify based on those predetermined classes. But in clustering, you just let the computer make groups of its own. And so don't be too bothered about using the correct terminology when you're in your discussion section, so you can use them interchangeably for now. Moving on, we also have regression. And regression is basically observing data and determining how different values or different variables of the data are correlated. So your model would try to fit a mathematical function to your data that describes the relationship between the different variables. For example, this is on the x-axis here, I have my sleep in hours, and on the y-axis, I have my grumpiness, and you can see that they are linearly related. So the more sleep I get, the less grumpy I am. So regression is very useful for analyzing trends. You can also use regression for like extrapolating and then predicting future outcomes. Next, we have reinforcement learning. And reinforcement learning is basically letting computers explore a complex scenario or environment on their own. And for every action that a computer takes, you reward them if they make a good action, and you penalize them for bad actions. For example, if you adopt a dog and you want to train the dog to do certain things, you would like maybe sit when you ask it to sit. You would reward it with treats if it does sit on your command, but you wouldn't want to reward it with treats when it doesn't sit on your command. So that way you're trying to, by reinforcing that habit into the dog, you're trying to teach different skills. And so that's the basic idea of reinforcement learning. You throw a computer into like an unknown environment, you give it like certain actions that it can do, and then you let the computer learn by trial and error what the right things to do in that environment are. Next, we have fuzzy logic. Fuzzy logic isn't a machine learning algorithm or concept, but it's still an important concept to understand. When you answer yes or no or true or false to a question, you're using like Boolean logic. But if your answer lies on somewhere on a spectrum, you're using what's called fuzzy logic. For example, if you just answer yes or no, when someone asks you if it's cold outside, that's Boolean logic. But if your answer has like more details, like it's slightly cold, or it's very cold, or it's not cold at all, that's fuzzy logic. And fuzzy logic is more informative, and you would like to have fuzzy logic in your machine learning models, but it also makes your models a lot more complex. So these are some tools that you can use in your solutions, and you can like mix and match, combine different tools. For example, I could combine CNNs. CNNs are basically models that help you do computer vision. So CNNs with fuzzy logic, and then you could feed it different images, and that the model could like classify images into not foggy, slightly foggy, very foggy based on the input. So don't let these tools limit you. You can be as creative, as imaginative as you want. You just use your intuition on what computers are capable of doing, and try and come up with innovative solutions to our climate problems today. Because machine learning is a very nascent field and it's growing really fast. So pretty much what you can imagine, you can come up with. So the different ways you could use these tools when you're coming up with ideas is prevention, regulation, or correction. Prevention is basically how you can use machine learning tools to prevent future damage, prevent additional damage, for example, wastage and pollution. Um, so regulation is basically monitoring certain harmful activities, even though they might be important, they could be very damaging to our environment. So we want to regulate those activities. So we also need to look into how you can limit such activities via regulation. And correction finally is how we can make amends for our past mistakes, like how we can maybe reduce the holes in our ozone layers and reduce the greenhouse gas gaseous levels in our atmosphere. So now we're going to go over our three main discussion topics. Um, so the way it's going to work is that there will be three different topics. We will explain our topics. You will get one topic, and so there are three topics, three breakout rooms. Within your breakout room, you will be brainstorming on how machine learning can help solve issues within your topic. And then you're also going to dig deeper in the way that you're going to come up with a pros and cons list for your solutions. Are there like administrative or political issues with implementing your problems? Are they long-term? Are they short-term? Will there be technological barriers? And then when we all get back to our main room, we'll be sharing with everyone else what we came up with. I'll pass it off to Albert to discuss the problems with electricity systems, buildings, and cities today.
Thanks, Aman. So our first category that we're going to be talking about is electricity systems, buildings, and cities. So here's some issues with electricity systems, just to get you brainstorming and stuff. So energy supply and demand right now is not being accurately calculated. This is important because if we're able to forecast how much energy different electricity systems need, or how much people need the electricity in a certain area, it'll make our energy processes much more efficient, and it'll decrease the amount of waste that we're producing. There are also natural gas pipeline leaks. These are important because obviously natural gas pipeline leaks get into the air and they're just completely unnecessary because it was just an accident. So we need a way to detect those. We also have trouble modeling what emissions are at a given moment, which is kind of a problem because if we don't know how bad we are right now, then how are we supposed to get better? And how are we supposed to accurately determine how we can get better? And also, we want to convert people to clean energy sources. But the thing is that you can't just like put clean energy in an area. You need data from that area. And some areas are really hard to get data from, and you don't really know exactly where to put it or how to cater to the individuals living around that certain electricity system. Now we'll go over some issues with buildings and cities. As with electricity systems, we actually have a lot of issues forecasting the amount of energy buildings need. And so if we're able to do that, we can better and efficiently plan how much energy a building necessarily needs and how much we need to produce. Also, I'm sure you have like left your light on or left your like oven on or something like that. That kind of all wastes energy. So we need some way to be able to turn on and off appliances to make it better. Also, energy use across buildings isn't being modeled. Some of the best ways in order to decrease the amount of energy that we're using is to like work as a group. And like if we divide up cities and we're able to model the energy use across buildings, it leads to more efficient energy usage. And our next topic is transportation industry and geoengineering.
Yeah, thank you, Ava. So some issues of transportation. Globally, about 25% of energy-related carbon emissions are from transportation, but we also have to take into consideration that some modes of transportation are dirtier than others. So road travel, for example, is the dirtiest overall, just by virtue of the fact that there are so many more cars and trains and trucks compared to other types of vehicles. But air travel is dirtiest per capita, because for each flight, planes use much more carbon intensive fuel than other vehicles. And a really big issue with the transportation industry is that there has been little progress towards decarbonization overall. And then some issues with industrial processes. Globally, there was an excess inventory of in 2011 of about $8 trillion worth of goods. And you can imagine that it's not probably getting much better over time. And that excess inventory causes serious issues because that means we are producing emissions to create goods that ultimately are not consumed or have to be thrown away. And as they decompose, for example, if it's food waste, as those things decompose, they do contribute significantly to pollution. And we can also talk about cement and steel production, which makes up a greater than 10% of emissions from industrial processes. And then there's also geoengineering. It would be nice to eliminate greenhouse gas emissions entirely, but there are still consequences for past emissions, and we might need some crazy ideas. I know that this doesn't really tell you much, but it's to get you thinking that some researchers really suggest way far out there ideas that might sound crazy, but can be implemented using machine learning tools. And with that, I'll pass it off to Aman.
Okay, so I'm going to discuss some problems with farms, deforestation, and like stuff like natural disasters. First of all, I'm going to cover the issues of farms. Okay. So some certain processes such as tilling disrupt the soil's biodiversity and also the chemistry. So it can lead to desertification over time. The usage of so a lot of farms, especially in developing countries, use chemical pesticides and fertilizers in excess, and that can lead to pollution of soil. That can lead to the seepage of chemicals into groundwater. That can also pollute nearby water bodies. Also, meat production and like rearing livestock is very inefficient. There is a stat that around 3.2 pounds of grains are needed to make 1 pound of chicken meat, and that is like the most efficient meat. And there's also huge wastage of manure and water due to inefficient irrigation systems, and especially in developing countries. Next, I'll cover issues about deforestation. So as you are all aware, we are at an all-time high deforestation in recent years. And if Jason could open this website, we can look at this really alarming statistic. So if you look at the number at the top, that is the hectares of forest that have been chopped down or like burned this year within like 40 days of this year. And that number is like rapidly increasing. So it just points out the extreme exploitation of our natural resources that is taking place today. And if we go back to the slides, we can see that deforestation also leads to other problems such as soil erosion because trees aren't able to hold on to the soil. There's a lot more flooding. There's also excess greenhouse gases in the atmosphere since there are no natural cleansers of the air. And also, it also leads to a lot more forest fires because trees are known to bring down local temperatures. There are also other environmental problems that we need to keep in mind. Deforestation itself is predicted to cause an extinction of 28,000 species of animals within the next 25 years. Animals are being forced out of their habitats due to like human encroachment and also because of the pollution of their habitats. We also need to keep in mind that there are certain natural disasters and spread of diseases that we can't we don't have full control over, and which also impact our environment. For example, volcanic eruptions, earthquakes, hurricanes. And so we even need to come up with solutions to these problems. Jason will be launching a poll now to gauge interest about the different topics so that we can split everyone up into breakout rooms.
Okay, super sorry y'all about breakout rooms ending so abruptly. I actually don't know how to extend the times on the breakout rooms, but I hope that we did have some good discussions. And actually, we were hoping that one person from each breakout room could briefly share what was talked about, and then Ava, Aman, and I will close with some ideas that hopefully you all will find interesting. So let me start up the screen share again. And Ava, do you want someone from your group to share first, perhaps?
Yeah, so if anyone from my group maybe wants to volunteer to just bring up like an idea, we can have multiple people as well. I know we got some good participation, so if anyone wants to just bring up something that they said or a solution that they said. I can start with like one thing that we did talk about. One thing that we talked about a little bit was we kind of got cut off at the end, but I guess like the last thing I was saying was making sure modeling a way or creating like a forum online to be able to see if buildings are reaching their target energy goals, and making that available publicly so that people feel more of a pressure to be able to make more sustainable solutions to like their actions every single day. So that was one thing that we went over.
Maybe just to chime in, we also talked about, how to use ML to place data plants, and maybe we can train some sort of model that approximates some optimal training plant location thing. But actually, Nina in our group brought up a really good point, which is that sometimes these algorithms can operate and kind of, affect Black and brown communities disproportionately more without that necessarily being reflected in the data that's being collected. So while we do obviously want to use machine learning to its best capabilities, we also kind of have to question, like, where did we get the data from? Where didn't we get the data from? Is the data biased, and all these kinds of considerations too.
I guess one other application that our group talked about was like, in terms of like natural gas pipeline leakage and stuff like that, using like computer vision and stuff to detect defects in the manufacturing at manufacture time instead of waiting for it to be deployed into the wild to figure out if there are problems. So.
Cool, thank you. That really awesome ideas. Does someone from my breakout room want to talk about what we discussed regarding transportation industry and geoengineering? I know someone brought up Google's servers being optimized with machine learning systems. Someone else brought up talking about geoengineering using machine learning. All right, I'll go ahead and, oh, sorry.
I guess I'll go because it seems like we had a quiet group. Sorry to cut you off, Jason, but we had an interesting discussion that John brought up where Google actually saved money by making their servers more efficient because, servers chug a lot of energy and they need specialized like liquid cooling. And it was an interesting case that doesn't happen very often where profit incentives line up with actual climate solutions. So that was interesting to think about, but it doesn't always happen.
Yeah, thank you. And lastly, from farms, forests, and societal impacts, what did you guys all talk about?
So we tackled 4 different topics. We tackled farms, deforestation, natural disasters, and biodiversity. I can start off by talking about biodiversity. And a problem that we noticed with biodiversity is that since like a lot of species that we're going to work with are already endangered and critically endangered, we have very less data to deal with and like to train machine learning models on. But an idea we came up with was maybe simulating sort of ideal environmental conditions that we could use to rekindle population levels of, say, a species that is close to going extinct or is endangered currently. And I'll let someone else talk about the other things we spoke about.
Yeah, so we also talked about natural disasters, and like one of the solutions we thought of was to use like the predictive power of ML to be able to pinpoint conditions for like natural disasters like hurricanes, forest fires, earthquakes, and essentially like predict when they would happen, and so that we could use that to prevent like damage or better prepare and like essentially save lives in the process. And then also another solution was like how we could use data from previous natural disasters to find which communities were like the most affected by these disasters, and like we could help provide aid better.
All right, really awesome stuff from all the groups. Really great to hear all the ideas that were being discussed. Now, Aman, Ava, and I have a little bit of a confession to make that we are not the first group of machine learning enthusiasts to talk about machine learning for climate change. And in fact, what we all did very quickly over the course of roughly 1 hour was recreate a paper that came out about 2 years ago now, because it's 2021. Actually, drop the links to it in the chat if you all are interested, and it'll also be mentioned on one of the resources slides. But right now, we're going to do a quick recap of what solutions were discussed in that paper and how close some of y'all came actually to pretty much getting everything that they talked about. Ava, would you like to talk about electricity systems?
Yeah, sure. So I think my group really went above and beyond in terms of solutions for electricity systems by taking into like race factors into account about where we want to build our electricity plants that really wasn't talked about in the paper. So I think that's awesome. But yeah, we really hit the mark and went above and beyond for forecasting supply and demand, reducing life cycle fossil fuel emissions, like, creating sensors to make sure that there's no pipeline leaks. And also modeling emissions for power plants and improving clean energy access, approaching low data settings. We really all hit the mark on those ones. Like the stuff you guys talked about in the breakout room was very, very similar. So yeah, I think that we did a really great job for this in terms of recreating the paper. And then the next is solutions for buildings and cities. So we did run out of time a little bit, but just to talk about some of the other stuff that was talked about in the paper. So modeling energy usage in buildings definitely is something that's important. And, we talked about regression and using regression into modeling these. There are also things that were brought up in the paper, like smart buildings that use like decision trees, deep neural networks, and Internet of Things, which is pretty much the interaction of different tools in like one setting or one area. And, having these interact with each other to be able to limit energy usage and make it more efficient. And we also didn't get to this, but, in terms of city planning, we can use different machine learning tools in order to make more efficient cities. So for example, clustering anonymized credit card payments makes it possible to model different communities and lifestyles of which sustainability can actually be assessed. So those are some of the things that we talked about, but I think overall for my group, we really did a good job of recreating this paper and discussing.
Awesome. And as for transportation, we talked about some of these things here, and we didn't get the chance to get to it, but I want to elaborate on something someone brought up, which was talking about autonomous vehicles and how they may or may not be more efficient than human-driven vehicles that operate on perhaps fossil fuels. And first, for sure, having autonomous vehicles can be more efficient because they can do what's called platooning, which means that They might drive in a formation that reduces drag on all of the vehicles. And what that means is that per mile traveled, the gas burn or electricity burn, if they're running on electricity, is much less than if it was just a bunch of uncoordinated human drivers with our poor monkey brains, right? But we run into the issue of something called the Jevons paradox. I hope I'm pronouncing that right. I don't speak French, but I think it's Jevons paradox is what it's called. And the paradox goes something like this, which is that if we produce efficiency gains and we tell everyone, oh, we should all do this because this is much more efficient than what we were doing before, that may actually produce more emissions in the long term. And the idea being that, let's say tomorrow morning, Amazon, made a huge announcement and said, hey, all of our deliveries will now be made via like drones or something like that, which, maybe they're electric drones and they're more efficient than human drivers with, their trucks and all that. But the issue might be that all of a sudden, because everyone thinks, wow, it's so much more efficient, they start ordering tons and tons and tons of stuff. And all of a sudden, our global production processes go into overdrive and we're producing way more things than we need to. Or, for example, transport. If we say, oh, public transport systems are now highly optimized and machine learning optimization algorithms and recommendation algorithms can get you from point A to point B on public transport really well. But then if people start using that even more, again, we run into the problem of, because there's a perceived increase in efficiency, we use more of the resources. So in the long term, it actually causes a decrease in efficiency. So not strictly machine learning, but thinking about the externalities long term, how might machine learning tools actually backfire and cause uncertain impacts where maybe it'll make things worse. And then as for industry, definitely talking about the impacts the internet and things like server farms have on carbon emissions, for sure. When profit incentives align with going green, we can convince companies to do that. But that may not always be the case. And something else that's interesting, I think we didn't really get a chance to talk about too much, is that machine learning tools in recent years have been used to help guide material science research, and that can help us, find more clean materials and catalysts. And machine learning tools in that regard are helping human experts to find good leads to pursue in their own research. And then geoengineering was the last thing we talked about. We had a really good idea about carbon dioxide sequestration and removal. And certainly that is a thing that is happening. I believe this is a picture of a plant from Iceland. I think it's Iceland. And those are giant fans for the purpose of sucking carbon dioxide out of the atmosphere. You can debate the efficacy of placing this in the Icelandic wilderness where there's not really much emission activity going on. But the point here is that machine learning tools can be used to help with figuring out where such plants can be best placed based on satellite imagery and determining, it sounds wrong the more I say it, the best place to put these plants for maximum efficiency.
Okay, so I'm going to discuss solutions related to farms and deforestation and natural disasters. So our group actually went over the solution about optimizing fertilizer and pest quantities in the soil. An initial test, we suggested that an initial test to find out if there's over pollution in a field is maybe testing nearby water bodies for contamination. And I was really impressed because this is actually something called precision agriculture that's already being adopted everywhere in the world. And so some pros of the solution are that it prevents desertification, pollution, keeps nutrient levels stable. And there's also less secondary pollution, but there are also some problems that come with the solution. They can be expensive for farmers in developing countries. Different crops and different types of crops need different nutrients and different nutrient levels, different amounts of water. So that is a problem that we need to figure out how to solve. And there's also a problem with scaling. How are we going to implement this solution into farms all across the globe? Then in regards to deforestation, we decided that we could use satellites to track, unlawful, so satellites and a computer vision algorithm, for example, to detect patterns of unlawful deforestation. You can also use machine learning to identify good chunks of land that could be used to grow trees, and maybe we could automate that process somehow. One thing we weren't able to cover was the detection of emissions. So you can use spectral cameras present in satellites as well as in the atmosphere to detect exactly where certain gaseous emissions are coming from. And this can help the government, locate certain industries and certain companies that are violating and exploiting the environment, and the government can maybe tax them or like penalize them. Moving on, we also discussed some solutions about natural disasters. Like we said, using previous examples of natural disasters to identify worst affected communities, using features, using variables such as the moisture in the atmosphere, the temperature to find out if there's like a forest fire that's going to take place, monitoring ocean currents and wind currents, and seeing if a hurricane could potentially form in a certain region. You can also, so the initial detection of like forest fires can help, firefighters better prepare for forest fires. Another information that was published, especially using machine learning models that predicted the spread of the virus, but we didn't adhere to it, and we failed to solve that problem as humans. But next time we should pay more attention to findings of like ML papers and machine learning algorithms. Yeah, so those were basically the solutions related to forests, deforestation, and natural disasters. Jason's going to guide us through a few resources that we accumulated that you might find interesting.
Yeah, thank you for that, Aman. We have a link to our slides here, and I think we sent them in the chat earlier. If someone could do that again, that'd be really great. There's also an overview of climate change impacts, and again, a link to the original paper that this event was based on. Today was really sort of like a very high-level whirlwind tour. We covered a lot of ground in 1 hour, so we didn't get the chance to touch on everything in great detail, but we do hope that you give the original paper a read, as it provides a lot more insights and interesting details. There's also a Notion page that someone put together that's just like a list of companies working at the intersection of machine learning and climate change. And there's a few groups as well, such as Climate Action, that is the wrong link, climateaction.tech and the Climate Plus AI Initiative, and some other various groups and papers that are listed on this page here. Again, you can find these all on the slides that should be linked in the chat right now. So we'd like to thank you all for coming. And if you would like to input the attendance code, it is Wally. Yeah, thank you.
Good job, everyone. That was very interesting and cool.
Thanks, everyone.